Boa noite a todos, bem-vindos a esse webinar que nós preparamos com muito carinho para vocês. Meu nome é Ana Maria Bride, eu sou coordenadora do Grupo de Pesquisa e Análise de Carnes da Universidade Estadual de Londrina. Londrina está localizada no norte do Paraná, e o Paraná é o estado maior produtor de carnes do Brasil, quando a gente soma a produção de carnes de suínos, aves, bovinos e pescados. Então, é uma universidade muito bem localizada no meio produtivo de carnes. O Grupo GEPAC é um grupo de pesquisa que envolve alunos da graduação, do curso de zootecnia e do curso de medicina veterinária da Universidade Estadual de Londrina, também alunos da pós-graduação em ciência animal, de mestrado e doutorado. Então, nós somos uma equipe imensa, né? Quase 20 pessoas que compõem esse grupo de pesquisa e análise de carne, e além de desenvolver trabalhos de pesquisa, nós prestamos serviços na parte de avaliação de desempenho, avaliação de carcaças e avaliação de carne para a indústria brasileira. Durante esse período de isolamento social, de pandemia, nós procuramos organizar esse webinar como uma forma não só de melhorar os nossos conhecimentos, mas também trazer um pouco de alívio para essas nossas angústias de estar perdendo pessoas queridas, ou também estar em isolamento social, sem poder se relacionar, que traz muita angústia e muita ansiedade nos nossos dias. Então, eu gostaria de agradecer imensamente todos os palestrantes que aceitaram vir palestrar conosco, e todos vocês que aceitaram também participar desse webinar. Nossa anfitriã será Luiene Moura Rocha. A Luiene foi minha ex-aluna de graduação e minha orientada de mestrado. Depois ela fez o seu doutorado em ciência animal na Université Laval, em Quebec, Canadá. Também ela fez 2 pós-doutorados no Canadá, uma na Université de Sherbrooke e outra no Agricultural and Agri-Food Canada, também na província de Quebec, no Canadá. Então, a Luiene, gostaria de te agradecer, Luiene, para aceitar essa missão de ser a nossa anfitriã nesse evento. Seja bem-vinda e vou passar para vocês e desejo um bom webinar a todos que estão nos ouvindo. Um abraço a todos.
Bom, boa noite, todo mundo. Obrigada, Bride. Primeiramente, obrigada pelo convite, GEPAC. E eu vou, então, agora, vou dar processo à entrada, à abertura em inglês, para falar com as pessoas. E se alguém tiver alguma dificuldade de entender, não precisa ficar constrangido, é só me falar e eu posso repetir, a gente pode continuar levando isso numa boa. Então, good night. I'd like to welcome everyone to the first presentation of the International Webinar of Beef Quality. This webinar is being organized by the Carcass and Meat Quality Evaluation Research Group, as known as GPAC. This group works under the supervision of Dr. Bride from the Universidade Estadual de Londrina. And the GPAC was created in 2006 by Dra. Ana Maria Bride and is currently composed of 15 undergraduate students and 7 graduate students in animal science and veterinary medicine from Universidade Estadual de Londrina. The GPAC works in a close collaboration with the Brazilian meat industry. They conducting research on pork and beef quality, as well as on fish meat quality. The Universidade Estadual de Londrina is located in the south of Brazil, in the state of Paraná, one of the largest meat producers in the country. To be more precise, they produce pork and poultry meat. So now that we are on time, it's my pleasure to introduce the first presentation of this international webinar. That's going to be Dr. David Hopkins. He prepared for us a great talk on the application of electrical technologies for beef processing industry. Please don't forget, once the presentation is finished, we'll be live with Dr. Hopkins for questions. See you soon.
Okay, so hello, my name's Dave Hopkins and I work for New South Wales Department of Primary Industry. So welcome to this seminar. I'm going to be talking about the application of electrical technologies for the beef processing industry. And just to give you some idea, if I can get this thing to work, you should see that. So you should see a map of Australia, and where the arrow is pointing is where I'm located, a place called Cowra, which is in the central west of New South Wales and is about 4 hours drive from Sydney. And you can see some of the other major cities of Australia. Just a little bit on New South Wales DPI. We are a large R&D provider organisation with something in the order of 650 sort of scientists, technicians, and we have research stations with various specialities that go across the whole of New South Wales. Just a little bit about me. So I like to ride motorbikes. I like to go kayaking with my wife down here in the lower left corner. Go bushwalking and camping, particularly with our second son, and travelling when we can. That's a little bit restricted at the moment, as you would understand. So that's a photo actually taken in Canada a couple of years ago. So just a little bit about my family. We have 2 sons and they're both married, and we have 1 grandson and are expecting 2 more grandchildren this year. So thinking about electrical technologies, the question we could ask ourselves is, what place do they actually have in the beef processing industry? And for this seminar, we're going to talk about 3 areas where they have some advantage and offer the industry something. The first is reducing toughness. The second is improving worker safety. And then the third is actually improving the harvesting of blood during the slaughter process. Now, in terms of reducing tenderness, improving tenderness, reducing toughness, we're really talking about having a focus on quality. And in Australia, extensive research was conducted in what was called the Meat Standards Australia program, and that's been conducted for both beef and sheep. But in the beef work, emerging from that program was a target pH decline window in terms of temperature. And now that's now set at 15 to 35 degrees, at which the pH needs to be 6 or below to get optimal tenderness and eating quality. And in some cases, in the beef industry, in Australia, for example, we know that electrical stimulation will be needed to actually achieve that window, but not always. And we'll come back to that point. If you want to have more reading information, more reading material, you can go to the MLA, Meat and Livestock Australia website, and look up Meat Standards Australia, and you'll find a raft of information there on that website. But just to sort of go through the pH temperature window, just to really make the point. So what we have here is we have the pH on the y-axis, and we have the loin temperature, in this case, on the x-axis. And we can see this solid line here would be considered an ideal pH decline. If the pH decline is too slow, then we can potentially get a phenomenon called cold shortening, which biochemically is actually due to the release of calcium from the sarcoplasmic reticulum, and it leads to premature shortening of the fibers before the fibers get into rigor. That's a particularly noticeable condition in lamb carcasses and goat carcasses, but it can also occur in beef. And you can see the area here where you would be prone to get cold shortening. The other extreme of that is actually heat shortening, where the pH actually falls too quickly. And this can have equally deleterious effects on the quality of the meat. And you get the occurrence of something that's like PSE meat that you experience or might observe in pigs. So we want to be in the middle, and that would be a reason to use electrical stimulation. Now, when we talk about electrical stimulation and we talk about electricity in totality, we need to remember that electricity ain't electricity. In other words, electricity can actually vary in the characteristics of how you actually program something. So you can have different frequencies, different currents, you can have different waveforms, you can have different wavelengths, and these things all have an impact on the actual result, as does having or varying the amount of voltage. And just to emphasize this idea about electrical stimulation, this is a diagram that's designed to illustrate what some people might have had experience with before. This is a typical high voltage stimulation system. And in this case, we can see that it has a constant voltage of 800 volts. And this whole rubbing rail along here will actually be at the bottom, will actually deliver the current. But what happens is that each carcass has a different resistance. So when those carcasses hit that rail, to keep the voltage constant, this is a constant voltage system, then the current will vary. And as a consequence of that, you tend to get a more variable effect. One of the developments about 15 years ago in Australia was actually to design new electrical technologies, and that included new stimulation systems. It's what we call new generation. And the reason for that is that it's got a controlled dose. In other words, each carcass is actually treated as an individual, and you have a series of electrodes. So if you can see the rubbing bar up the top here in the diagram, in the photo image, you can see that there's white insulators, and these white insulators actually segment the actual rubbing rail, the one that's got the current in it, so that each carcass gets an individual dose of electricity. And what happens is that when the carcass first hits that electrode, there's a small test pulse that goes into the carcass. It gives an indication of the resistance. And in this case, because the system is a constant current system, so in this case 1.6 amps, it will alter the voltage then according to the individual resistance of each carcass. Now, this means it's a much more flexible system, and it actually responds to the amount of resistance in individual carcasses, and it gives you a much more controlled dose. But not only that, the other thing with this system is that the wavelength and the pulse width are actually quite different. So the high voltage system has what we call a sinusoidal waveform. It's like an S, so it goes like this. You can see that what we call the medium voltage system, electrical stimulation system, has small square pulses in the red. And as a consequence of that, it also means that this system is actually safe. So what I mean by that is that in a high voltage system, you have to have it separated from workers, because as demonstrated in this slide, the peak voltage can be quite high, up to 1100 volts. And at 1 or 2 amps and at 50 hertz, which is the power that's going through this is lethal and it will kill you. By contrast, the medium voltage system, which has these small square pulses of narrow width, it actually is safe. And it therefore means that you don't need the amount of protection from workers from this system. This follows on then and means that it's actually a lot cheaper to install, particularly in existing abattoirs, because you don't need all the shielding that actually goes with this system. So there's a couple of advantages straight away from this system. Individual response, so it treats each carcass as an individual. You have the safety factor, and you also have a reduced cost if you want to install this system in an existing works, particularly. So what it looks like here in this slide, this is some beef carcasses going on the system, and you will see right at the top of the slide here in this carcass, the leg is on the rubbing rail, which has got the current in it, and you can just see the insulator. So each carcass goes along and it will have a series of different electrodes depending on the speed of the chain and how much you actually want to stimulate the carcass. So if you have a fast chain, then you need more electrodes and so on. And those things have to be optimized for each individual abattoir. As you can see in this picture, there's no shrouding that's needed around these carcasses or the system because, as I said before, it's actually safe and it won't fatally kill or injure someone if they actually were to come in contact with it. So, does it work? Well, let's look at some data. So this is some data from a more recent experiment that we conducted in China. And we've introduced this technology into China through a collaboration, one of the collaborations that we have with a Chinese university. And we have here some data from an experiment that looked at the effect of stimulation on beef carcasses processed through a typical Chinese abattoir. Now, there are three combinations of electricity that were tested, A, B, and C for simplicity. But those combinations were arrived at by doing previous work to this, where we actually looked at something like 20 different combinations of current, pulse width, and time to see which was the optimum. And these three were the ones that we emerged that we thought we would use for further study. And that optimization was based on the rate of pH decline. So we selected these three, and the characteristics of the three systems are described in the footnote of the table. So down at the bottom of the table, you can see that combination A or treatment A was 1 amp, the pulse width was 1.5 milliseconds, and that the stimulation lasted for 27 seconds. Now, these are not hard and fast numbers. They're indicative numbers. In other words, they could vary a little bit and you would still get the same response. Three variations. What you can see from this data is, firstly, that each of the stimulation systems increased the speed of pH decline quite significantly, in the order of between 10 to 8 degrees, roughly. And so we know that this is going to help these carcasses to fit into that window. And in fact, they all fitted into the window on average. But the stimulated ones were at the top of the window, and therefore you have some real surety that they're going to pass through, all the carcasses will pass through the window. The other thing that we can observe from this is indicated by the red arrow, and that is that the shear force was significantly reduced. And if you go and look up this study, you'll see that the beef, this is strip loins or loins, was aged for 3 different aging periods. So these effects are averaged over those aging periods. And you can see, in the order of nearly 20 newtons of improvement in the shear force of these loins in these particular carcasses. So this tells us that this is effective, and it's having a major influence on a trait that is related to the tenderness of the meat. The other interesting thing to note from this work are two things. Secondly, the sarcomere length didn't tend to actually differ too much. It was shorter in the control, but probably within the limits. If that control, the non-stimulated, had been, say, at 10 degrees, we would have expected that sarcomere length to be much shorter than 1.75 microns. The other thing to note is the effect of stimulation on the colour of the meat. And you can see in the last row that the L values, the lightness or darkness of the meat, as measured with a spectrophotometer, was much lighter in the stimulated product than it was in the control. And this varied according to the treatment, but certainly with the combination of treatment A. The other thing to note, of course, is that the ultimate pH values in these carcasses are all very good. And I should make the point that stimulation itself will have basically no effect on the ultimate pH values in beef. And the reason for that is that is driven by the glycogen supply, not by the speed of decline or the speed of, or the depletion rate of glycogen as muscle goes into rigor. So, to summarize the benefits, we can reduce the shear force, no doubt, in beef and in lamb and other species. We will increase the lightness often, but stimulation is not necessarily always needed, and we should bear that in mind. And I'll illustrate that in the next slide. So here we see some pH declines from some data from another experiment that we're involved in a few years ago. And what we can see is this is the window here. This is the ideal window. And we can see that the carcasses that were the control, which are these ones, the non-stimulated, just hit the top of the window. And in fact, the stimulated ones actually missed the window because the pH fell so quickly. And essentially, that was what we were trying to induce. Probably we were expecting a slower pH decline in the ones that weren't stimulated, given the type of cattle that we used. But this effect here, where we've stimulated and dropped, this is actually likely to be deleterious. In other words, we want to stay away from this because this is actually too fast. And what we find in Australia is that many plants who process particularly heavy grain-fed cattle do not stimulate those cattle because the pH will, as a result, fall too quickly. And this can have some negative impacts, particularly in the deep muscles of the hind leg. So stimulation is not necessarily going to be required in all cases. The way to determine whether you need stimulation or not is to measure the pH decline of a number of carcasses and see where you fit in terms of the window. And if your rate of decline is too slow, you'll need stimulation. If the rate of decline is fine or optimal, you don't need any stimulation. So electrical stimulation principally increases the rate of pH decline. It increases the amount of work that the muscle does, and as a consequence of that, it's like the muscle is running and it's actually using up the glycogen. There is some evidence that, in fact, because you accelerate the rate of pH decline, it can also accelerate or bring forward the onset of proteolysis, which is the degradation of myofibrillar proteins. And that's really associated with a change in the optimal pH and temperature of the enzymes that are responsible for that degradation. There is also some evidence that it can cause fiber weakening, and we see this in the next slide. And this is a slide that's taken from that work in China. This is an electron microscope image at 25,000 times. So very, if you like, blown up image. It's from treatment A at 0 days. And so there's no aging effect. And you can see in the portion that's got the blue circle around it, that actually at the sarcomere level, and this is the Z disc here, and you can see the other Z disc is here, but you can see that effectively the proteins have actually been, and the myofibrils have actually been separated. They've been actually like broken. It's like you've got a tear in the muscle. And so you can see this localized tearing in the muscle, both from stimulation and sometimes also from tender stretching. And this may contribute to increased tenderness, but it's been very difficult for anyone to actually quantify that effect. And so one would say that most of the effect of stimulation, by and large, is due to a change in the dynamics between pH and temperature during the onset of rigor mortis. Now, one of the other things that we can use electrical technologies for is actually to immobilize. And here we've got actually a photo of a sheep system, and I'll show you a beef one in a minute. But essentially, immobilization is the application of very high frequency electricity to carcasses, bodies, after they are actually slaughtered. In other words, after their throats have been cut. And it induces this tetany. And you could say, well, what do we want to do that for? And the reason we want to do it is because it reduces kicking and carcass movement. It also reduces, the hind leg kicking, so that when you go to shackle a carcass, and particularly in beef, then the leg is not kicking, as you might see. So the beef system looks like this. So essentially, it's a cradle. And in the cradle, we have 4 electrodes here, this plating, and these are live. Again, this is safe electricity. It won't kill you because of the pulse width that's used. But essentially, it's high frequency, something like 2,000 hertz, where we think of the medium voltage stimulation system would usually run somewhere between 15 and 20 hertz. This is 2,000 hertz. It's 1 to 2 amps, but very high frequency, small pulse width. And essentially what that does is it means that when a beef carcass is exposed to that, rolls into that cradle, the electricity is passed through the carcass or the body. That body will go into tetany and it will stop kicking, and you can then shackle it and then put the chain around it and lift it onto the rails, and it's safe, and it reduces any likelihood of the slaughterman being kicked and injured. And I've been in plants overseas where I've seen people who do that job of shackling actually wearing like baseball masks so that they didn't get their teeth kicked out. So this is a very practical and useful addition to the beef processing chain. The other thing to note about this is that it won't impact on the rate of pH decline, and that's because the electricity is at 2,000 hertz. It so quickly goes, it's got such a high frequency that it won't impact on the pH decline. So therefore, you can use stimulation down the chain further in the process if you need to. Now, another feature that unfortunately I can't show a photo of, particularly in cattle, and these are sheep, is the fact that we can use this electricity. We can change again the frequency and the pulse width and so forth to actually increase the amount of blood that we get out of the carcass by applying a particular electrical current to the carcass. In this case, it's a low frequency. We just talked about high frequency with immobilization, but this is actually a low frequency, 5 hertz, with a pulse width of small pulse width, and then say 0.5 amps. And it's essentially, again, going to have no effect on meat quality traits like pH decline. But what it does do, if you can increase the amount of blood that's extracted from the body in the drain area, it reduces the amount of wastewater that you, or the water that you need, and therefore create wastewater further down the chain because there's less blood that you have to remove from the system. It also improves the amount of blood that you can capture in the blood draining area. And so this is a really, again, an important facet of using electrical technologies to maximize processing efficiency. Okay, so to summarize, what are the benefits? Well, first, we can have reduced occupational health and safety claims. So you improve worker safety by the use of the immobilization system. You can have a system that incorporates both stimulation and blood recovery, so early after the sticking of a beef carcass, and increase the capture of blood. The other thing is that if we've got carcasses that have a slow pH decline, if we have a stimulation system, and even if it's the same system as the blood one, and we alter the characteristics of the unit and electricity, we can actually increase the tenderness of the product also, and that's also really important. On top of that, we will tend to reduce the variation in tenderness that occurs. So there's some of the benefits that we get from this system. So thank you for listening, and I hope that it was useful to you. If you want to do some further reading, there are some suggested papers that you can read to actually get more information on these technologies, in particular electrical stimulation. And thank you very much for watching and participating in these seminars.
So, hello everybody, we are back. Then before I call Dr. Hopkins, I just forgot, I was so nervous that I forgot to introduce myself. My name is Luiene Moura Rocha. I am an animal scientist, graduated from Universidade Estadual de Londrina, and I have a PhD at Laval University in animal science. My specialization are in animal welfare and meat quality. And I have 2 postdocs, one done at the Agriculture and Agri-Food Canada, and the other one in the Université Sherbrooke. Both are in Quebec, Canada. And it's a pleasure to be here with you today, and I'm really honored to be invited to be here. And now I would like to introduce our first speaker of the International Webinar of Beef Quality, Dr. Hopkins.
Hello.
Hello, Dr. Hopkins. How are you doing?
Good. Can you see me?
No, I can't.
Okay. Hang on.
Okay. So now I can.
Okay.
Hello. So on behalf of everyone here, I would like to thank you for the really great presentation that you prepared for us. And I also take this opportunity to thank all the GPAC organization, everybody that are on backstage. They are doing a really great work. And before I start with the questions, I would like to introduce Dr. Hopkins, and I'm going to read his CV, so his curriculum. So Dr. Hopkins, he has a bachelor's degree in agriculture from University of Melbourne in 1982. He has also a master's degree in agriculture from the University of Melbourne in 1984. He also has a PhD in meat science from the University of New England. And since 1991, he's a senior principal research scientist in the meat science at the Department of Primary Industries of New South Wales and the Red Meat and Sheep Development Center. And Dr. Hopkins is also currently an editorial board member of 2 different journals. So we have the recent patents on food and the nutrition in agriculture, and also Dr. Hopkins is the editor-in-chief of the Meat Science. So Dr. Hopkins, it's really a pleasure to having you here with us. And now that you are well introduced, do you want to talk something before we start with the questions?
No, look, just welcome. And yeah, sorry for my mobile phone going off when I recorded that.
Okay.
But look, it's just, I'm happy for people just to ask questions if there's anything that wasn't clear. I understand that I was pointing with my cursor when I was doing the talk at various things on the PowerPoint, and I realized, of course, that you couldn't see the cursor. So there might have been some things that weren't clear. So happy to clarify if I can people's questions or whatever. Yeah, so look, it's over to the people watching, basically.
Okay, so that's perfect. So I think that your talk was perfect, was really clear. I could understand really well. So I'm going to start the questions. So if anybody has a question, don't forget you can do it in English, in French, in Spanish, or in Portuguese. And our group are going to manage for us it. So while we are waiting for the warm-up, the audience for the questions, I would have a question, Dr. Hopkins. Well, since I work with animal welfare and meat quality, I was watching your talk and I was thinking, do you think that the electrical stimulation could help to revert the DFD meats since it can improve the tenderness and the color of the meat in beef?
Essentially, not really.
Okay.
Just because of the biochemical differences and the fact that DFD, of course, is a reflection of actually depleted glycogen. And so not really. And there's other things that you can do post-slaughter to sort of try and cope with DFD meat, particularly packaging systems. We've done a bit of work again with our colleagues in China, and you can actually use carbon monoxide in mat packing, and that will actually alter the color. But the problem is that you're actually potentially disguising a problem, and it might look good for the consumer, but it might not taste too good. So, this is DFD meat is it's an often talked about problem in the beef industry around the world, and some countries are much worse and have higher rates than other countries. And really, from your area of animal welfare and so forth, the things to do are all before the animals get to the abattoir. There's a little bit at the abattoir, of course, in the way you handle them, but so much is influenced by the systems of production, transport. They're the things that people need to focus on. And I'm amazed, actually, in some countries, people do a lot of work on DFD meat without actually going back to the source problem, which is actually how you look after the animals, how you feed them, how you transport them, all those sort of things. They're the things to look at. Post-slaughter, you're just trying to cover up a problem.
Okay, so thank you very much. So we have a question from Unicamp. So the question is, what is the better time to apply electrical stimulation for improving tenderness? And what effect does stimulation have on leather or muscle?
Okay, so the simple answer to that question is it's better to apply as early as you can after the death of the animal, because at this stage the muscles are more responsive in terms of their nervous system, and that's why you can actually use lower voltage systems early on, and if you go later you tend to have to use higher voltage systems to actually overcome the depletion in the nervous system. So as early as you can is the simple answer. What effect does it have on leather? It should basically have no effect on leather, because that's a co-product that comes from further processing of skin. And of course on muscle, well, essentially what it does is what I've described. It increases the rate of pH decline. In other words, it increases the speed at which rigor mortis is entered into, and as a consequence of that, you are then alleviating any potential problems with particularly cold temperatures, and therefore improving the tenderness. Now, the thing to say is that if you actually age meat for a long time, often non-stimulated meat, if it is not severely shortened, will actually come down and meet stimulated meat. But stimulated meat will get there a lot quicker. And that actually then saves you the time of having to age meat for long periods of time.
Okay, that's good. So we have another question. So good night. The change found in color of the meat could make the marketing of this product more difficult, or is it something subtle?
Yeah, subtle. Yeah, it's a good question. In in heavy beef, and that's why I talked about the fact that in heavy beef you don't necessarily need to stimulate, and you can actually over actually stimulate, and that product you could potentially turn into more like PSE in pork. You said you get this effect in beef, so that actually can be a problem, and that's why a lot of processors in Australia, for instance, that process heavy grain-fed beef do not stimulate because the pH already falls fast enough. So for some beef, particularly for lightweight, leaner grass-fed beef, there's potentially some advantage in colour. So it's not more difficult. But for heavy grain-fed beef, you don't want to do it because it might be difficult because you actually end up with a very pale meat.
Okay. So, okay, another question. A culture like Brazil, where 80% of the herd is composed of zebu breeds, do you believe that the electrical stimulation could be an option to improve the tenderness?
Absolutely. And in fact, I would suggest that particularly those that genetics out of a grass-fed system, you would almost need to do it, I would suspect. Otherwise, the product that you are going to produce is going to be suboptimal in terms of eating quality. So yes, absolutely. And there was some work done in Australia a few years ago. Well, it's probably more than a few years ago now, by a PhD student looking at particularly Bos Indicus type cattle stimulated, and just to actually look at the effect in terms of proteolysis and what happens there, because of course you would be aware that zebu breeds, Bos Indicus, the levels of calpistatin in relation to calpain is actually different. And so there was work done, and it clearly demonstrated again that there's a benefit from stimulating. And so I would actually say, as I said before, for that type of animal or for grass-fed system, it would almost be mandatory to stimulate to actually have decent eating quality.
Okay, that's really interesting. So we have another question. Any experience of using European electrical stimulation in poultry and swine slaughtering procedure?
That's really easy. No.
No.
No, I don't have any experience about using it in poultry. I mean, the poultry industry, of course, uses a type of stunning to actually stun birds. So because it's all done automatically in many places, but it's not an area that I have worked in. And swine slaughtering, stimulation itself again wouldn't be an advantageous thing by and large. It's been investigated, and it has shown some benefits. Again, some work done in Australia by a researcher called Heather Channon. Channon is her surname. She's done some work looking at electrical stimulation in pork, and it actually did show some benefits in some cases. But pork, again, is something that usually doesn't suffer from a slow pH decline. It's actually the opposite, and that's why the analogy with heavy grain-fed beef and PSE in pork is similar. And so there will be many cases where you would not definitely want to stimulate pork carcasses. There might be particular carcasses that would benefit, but in general, I think no.
Okay, that's great. Thank you. So do we have some more questions? Okay. So in the study showed by you, the meat did not present any abnormality like DFD meat. So how is the behavior of this type of meat using electrical stimulation?
Well, I mean, if you go back to the principle of what electrical stimulation does, essentially it speeds up this process. So this is what happens in muscle. Forget the camera, right? This is when you're doing this, you're actually converting chemical energy into mechanical energy. And so when you stimulate, essentially in the muscle, you're speeding up that process. All right. So it's using the reserves of glycogen. Now, beef that goes in with low glycogen levels will not respond because it just doesn't have the glycogen, and that's why you'll end up with the high pH. ultimate pH because you don't have the glycogen. Sure, it will speed it up, but you just don't have the reserves there. And as I said before, it's very important to realize that essentially stimulation is not going to do anything to ultimate pH. Okay. Think about the question before about DFD. You want to fix that problem, fix the animal production system, the animal slaughter handling system.
For sure. Okay, that's great. So just before I do the next question, I would like to ask you, so when you use the electrical stimulation, what do you do with the muscle fiber? You rip it out because of the stimulation, or you just activate the calpastatin proteolysis?
Yeah, that's, well, essentially just go back. Again, it's essentially just speeding up the glycolytic pathway, right? That's what you're doing, okay? And that's actually if you like, essentially making sure that the muscle doesn't get to a state where the temperature has dropped too much and you get what we call premature shortening. And that's to do with the flow of calcium out of the sarcoplasmic reticulum. What was the rest of the question? Sorry, I've forgotten.
I was asking if the tenderness that we get is because of the rip out of the fiber, the muscle fibers, or because of the calpastatin induction proteolysis.
It's principally because you stop premature shortening of the sarcomeres. That's the main reason. That's the main thing that it does. As I said in the presentation, there is some evidence that you actually will increase the rate of early proteolysis because of the temperature and pH interaction. So what happens is you've got earlier activation of that calpain system, and therefore that drives proteolysis and therefore degradation. The pulling apart of the fibers, it's very difficult. There's been no experiment to actually quantify that because you're talking about looking at the micro level in the muscle, and you can get localized breakage essentially or disorientation of the proteins and the myofibers, right? I mean, there's evidence that happens, and it's to do with localized stretching and contraction, and probably associated with also calcium, rising calcium. But that in itself, you can't really say, there's no good evidence to say that that's the thing that really contributes. It might be a small contributor.
Okay.
And proteolysis increased early, yes, is a contributor, but the major thing is actually keeping those fibers from doing this and the sarcomeres being short so that you have longer sarcomeres, because that's the thing that has the biggest impact. Okay,
that's perfect. So linking with the question, we have another question here. If any proteolysis data on that side would explain the results. I think you just explained it, but if you want to add some more comments. So I think we can...
Yeah. So as I said, there was some work that was done a number of years ago in Australia by a PhD student called Ben Gazensky, and his work's published in Meat Science. If you searched under Carrick Devine, I think was one of the other authors from New Zealand, they actually did some work in Bos indicus looking at stimulation, but also looking at calpain's calpistatin. So there's more information available.
Okay, that's good. So thank you very much. I think we covered this part. So some more questions? Okay, so good morning. Can this technology help improve meat quality threads of frozen beef?
Well, if you do it before you freeze it, yes.
Okay.
but not afterwards. If you then thawed frozen beef and applied other technologies, you could improve the tenderness, but essentially you'd be wasting your time with electricity, I think.
Okay, so thank you. So do we have some more questions for Dr. Hopkins? Okay, we have one. Try stimulation with small pulse between 10. Do you think that worked better than just one longer?
Twice stimulation. I guess what your question is in suggesting that you stimulate once and then you stimulate again. And essentially, in the new system that's been developed in Australia, what we call new generation system, each carcass is on one electrode at any one time. So in fact, depending on how many electrodes you have, that carcass is stimulated more than once. It's stimulated on that electrode. There's a break with an insulator. It goes to the next one. It's stimulated again. There's another insulator. Okay. It's stimulated again. So it's a continual process. And how many insulators you have is determined by the speed of your chain. So if you have a very fast chain, you need to have more insulators and more electrodes so that you get enough time of stimulation, because the length of time is also important. And you need probably, as a rough guide, maybe 35, 40 seconds of stimulation to get optimum time. And the data I showed you from China had some different lengths of time in it, and I think the lowest was 27 seconds, and then there might have been some other variations. But you sort of need to aim for that 30 seconds. So it's actually getting stimulated more than once. In the old systems, where you've just got an electrode that goes along and it's alive all the time, the carcass is being stimulated all the time, but they usually bounce off, come back, bounce off, come back, that sort of thing, particularly if it's high voltage.
Okay, so thank you. So do we have, okay, we have another question here. So how did the consumer market accept the use of electrical stimulation there?
Oh, the consumer market doesn't know anything about it. I mean, what consumers are interested in is a product that is tender, tastes nice, looks good.
Nice, yeah.
And these are things that stimulation can help with, particularly the first one. You know, like it's more tender. It might improve the color a little bit, but there's lots of other technologies you can use to do that also. So consumers, by and large, are not interested in the system of production that you get there in terms of processing. What they're interested in the final product. So it's just about making it the best product that you can.
Okay. So, okay, another question. So in terms of sensory texture, electric stimulation offers an advantage for muscles with high connective tissue content?
Essentially, no, because you're talking about the other dimension of tenderness, which is the connective tissue structure. And essentially, stimulation's not going to do anything to that in itself. It's working on the myofibrillar proteins, the proteins that are in between the honeycomb, that connective tissue. So that's what it's working on. So muscles with high connective tissue, you got to do other things, cook them at different temperatures, or you know, use other tenderizing mechanisms. So no, but it's like benefits. They still have myofibrillar proteins in them, and they still will shorten. So you still do get a benefit, but you're not going to take away the high connective tissue effect.
Okay, that's perfect. So I'm just received a message here that we had a question if the electrical stimulation is something that has been invited to come to Brazil, or you think in do some projects in Brazil?
Okay, I see a comment. I see a comment here that says that Dr. Bruce Marsh used to say that electric stimulation was invented for Brazil. Does that mean invented for Brazil or in Brazil?
Well, I really think that it's for Brazil, because I think that he's talking about the Zebu breeds that we use.
Yep.
So I think that it fits perfect with our scenario.
Yep. And of course, he's one of the early fathers of muscle structure and so forth. So yeah, it's probably a fair comment. And in Australia, in the northern part of Australia, which is largely Bos Indicus based with Brahman and so forth, then in a lot of those plants, electrical stimulation is used. When you get to the southern part of Australia, which is a bit more like Uruguay and Argentina, where we have the more British breeds, then the use of stimulation is less required. I think there was another question there that I didn't get to answer.
Yes, exactly. We had another question. Yes, this one. So to what extent it's worth to use electrical stimulation to reduce post-mortem carcass chilling time?
Well, that's a question that's sort of it needs to be answered and framed in the context that postmortem chilling time is something that actually is dictated by the rate of temperature decline. Okay, where stimulation is affecting the rate of pH decline in relation to temperature. So you still got to get rid of the heat, and so it's not really necessarily going to have much to do reducing the actual chilling time, because you've still got to get rid of the heat. It's actually the relationship between the pH and the temperature that stimulation is largely affecting, not the heat that's generated.
Okay, so we have one more question. Can the electrical stimulation extend the shelf life of the meat?
I would just say probably in general, I wouldn't say that that's likely to happen. I mean, shelf life itself, the major contributor to shelf life is actually the hygiene and the microbiological sort of environment of the meat and what ends up on the meat. And you know, that's the thing that has the biggest impact. Stimulation in itself is directly not really going to have any effect on that. That's another processing solution, which is good hygiene and using obviously methods of storing meat, you know,
Okay.
low temperature, below